The deadliest creature in history is not a lion, not a shark, not a snake. It is the ordinary mosquito. Every year, these tiny killers take the lives of nearly 700,000 people around the world. Malaria, dengue, Zika, chikungunya, yellow fever – all these diseases are spread by common mosquitoes you can barely notice on a summer evening. And so, in the summer of 2025, China breeds an army of giant mosquitoes in secret laboratories and then releases them into the wild, on a massive scale, voluntarily. Why? No one understands. What is hidden behind this frightening experiment? Mosquitoes carry more deadly diseases than any other animal on the planet. They kill people in huge numbers on every continent except Antarctica. In tropical countries, malaria kills one child every 2 minutes. Dengue infects millions of people every year, the Zika virus causes serious birth defects in newborns, and chikungunya causes severe joint pain that can last for months. In July 2025, an outbreak of chikungunya erupted in China's Guangdong province. In just 3 weeks, more than 6,000 people fell ill in a single city, Foshan. Hospitals were overcrowded. Authorities prepared for a large-scale epidemic comparable to the COVID-19 pandemic. Isolation measures began, mass disinfection of streets, testing of the population. Epidemiologists predicted a real disaster. And then China launched an incredible experiment that shocked the whole world. In the laboratories of Sun Yat-sen University, giant mosquitoes were bred with a metallic sheen and massive bodies. They were several times larger than normal, the size of a large coin. They had huge wings, enlarged heads, and long legs. But the strangest thing was they did not bite people. They didn't even have the right mouth parts to do so. People did not understand what was happening. The internet exploded with conspiracy theories. Was this a biological weapon? A leak from a secret military lab? A test of a new surveillance species? An attempt to control the weather? Some experts suggested it could be a targeted weapon. Just one of these mosquitoes would be enough to cause panic in any country in the world. The authorities remained silent. There were no official explanations. Only brief statements that larvae of times Toxorhynchite splendens times mosquitoes had been released into the natural environment. The name sounded ominous, like the code name of a secret project. The media wrote about cannibal mosquitoes, elephant mosquitoes, lab-made mutants. But within a month, cases of people infected with the dangerous chikungunya virus dropped significantly. Without vaccination, without chemical treatments, without mass quarantines, the epidemic slows down significantly. And then the world learned the truth about what China had really done. This giant mosquito was not a mutant or a weapon at all. It was times Toxorhynchite splendens, times a large but completely harmless species to humans. Adult mosquitoes feed only on plant nectar, but their larvae are true predators. They live in the same stagnant water as the larvae of dangerous mosquitoes and methodically eat them. One times, Toxorhynchites times larva in its lifetime can eat between 80 and 100 larvae of times Aegypti times the main carrier of chikungunya, dengue, and Zika. Thus, for the first time in history, China used predatory mosquitoes as a biological weapon against an epidemic. The number of dangerous mosquitoes in the entire province fell by 78% in just a few weeks. It was a revolutionary approach. Instead of chemical pesticides that kill all living things, nature itself was fighting nature. At the same time, the authorities released more than 5,000 fish into the water bodies, which also feed on mosquito larvae. In the future, this method could save tens of thousands or even hundreds of thousands of lives each year in countries with a tropical climate. Already, dozens of countries are studying the Chinese experience. Brazil, Indonesia, Thailand, Kenya, all of them are considering breeding predatory mosquitoes to fight epidemics, and China has no intention of stopping there. In the same year, it shocks the world once again. This time, bees have come under its control. This insect looks like an ordinary worker bee. It buzzes, flaps its wings, lands on flowers. However, inside it has a chip, electrodes, and a neural controller. In reality, it is not quite an insect. It is a controlled scout, a living drone that follows human commands. Chinese scientists from the Beijing Institute of Technology, led by Professor Zhao Zheliang, managed to create the lightest neurocontrol system for an insect in the world, only 74 milligrams. This is thinner than a human hair and lighter than a drop of water. The device is attached to the bee's back like a miniature backpack. A thin polymer plate, the thickness of an insect's wing, is equipped with microchips and an infrared receiver. 3 ultra-thin needle electrodes are inserted into the bee's brain. When an electrical signal is sent, the bee turns left or right, flies forward, backward, or hovers in the air. The accuracy of following commands exceeds 90%. Imagine the possibilities of such enhanced insects. Cyborg bees are the perfect super spies. They are completely unnoticeable. No one would suspect an ordinary bee of espionage. They can fly through open windows, ventilation shafts, any narrow passages. They can reach places inaccessible to any drones. They are suitable for surveillance, delivery of microsensors, microphones, and even nanoprobes the size of a speck of dust. Imagine the possibilities. A bee lands on a windowsill in an enemy's office and leaves a microscopic bug for eavesdropping. It penetrates a secret facility and takes air samples for traces of chemical weapons. It discreetly attaches a transmitter to the clothing of a target or to a vehicle. A bee can stay in one place for hours, pretending to collect nectar from flowers. No one would suspect the insect of spying. They are everywhere, part of ordinary nature. It can follow a target, moving from tree to tree, transmitting location coordinates. It can record conversations through a microphone the size of a grain of sand. It can take photographs through a lens as thin as a human hair. Such bees can be used for reconnaissance in disaster zones where it is dangerous for humans to be, in radioactive areas where any equipment would fail, at restricted military facilities where no drone could enter, in the residences of politicians where the most advanced security systems are in place. For now, the technology has limitations. Full autonomous operation requires a battery weighing about 600 milligrams, several times heavier than the bee itself. Such a load seriously limits flight range and duration. In addition, control currently works only for flight direction movements of the legs and abdomen remain uncontrolled. But Chinese specialists are actively working to solve these problems. They are creating ultra-miniature power sources, experimenting with solar cells only a few atoms thick. They are improving AI-based control algorithms to achieve complete control over the insect's behavior. This is not just some one-time experiment or science fiction. These are real laboratory tests with live bees that have already shown impressive results. Cyborg bees can already fly distances of up to 5 kilometers, performing complex maneuvers on operator commands. In the future, such cyber bees will be able to perform not only reconnaissance missions. They could be used to search for survivors under rubble after earthquakes, to monitor environmental conditions in hazardous areas, and to deliver medicine to the most hard-to-reach places. Now imagine not tiny bees, but cockroaches, the most resilient creatures on the planet, the ones that would survive even after a nuclear war. Dozens, hundreds of these creatures with electronic backpacks on their backs, running on command, turning where needed, transmitting live video in real time. This is no longer nature. This is an army of biomachines assembled on a conveyor belt production line. In Singapore, Japan, and Germany, work is in full swing on creating an army of cyber cockroaches. At Nanyang Technological University, a fully automated production system has been developed. Each specimen can be prepared for action in just 68 seconds. The process looks like a scene from a horror movie. The cockroach is placed in a special chamber and immobilized with carbon dioxide. An industrial robotic manipulator with computer vision locates the exact point on the insect's back. Then, with surgical precision, it installs an electronic backpack with microchips and an antenna. 2 electrodes with ultra-thin needles and hooks are inserted into the cockroach's body near the front legs. The system is activated and the cockroach becomes a remotely controlled soldier. After the upgrade, the insect moves along a given path, turns right or left, speeds up, and stops on remote commands. It can carry a miniature camera, microphone, temperature sensors, and chemical composition sensors for the air. It is capable of transmitting live video at distances of up to 1 kilometer. Cockroaches are perfect for secret operations. They are everywhere, living in every corner of the planet, resistant to radiation, chemicals, and extreme temperatures. They can go without food for weeks. They can squeeze through cracks just a few millimeters wide. They climb walls and ceilings. They can move at speeds of up to half a meter per second. They are used for reconnaissance in hard-to-reach areas. for penetrating buildings through ventilation systems and sewers, for inspecting rubble and ruins after disasters, for observation in zones of chemical, biological, and radiation accidents, for searching for explosives and drugs, for eavesdropping on secret conversations. Cockroaches do not require expensive technical maintenance like drones. They do not crash in strong winds. They do not break when colliding with obstacles. They are almost impossible to detect. Who would pay attention to an ordinary cockroach? They are the perfect living machines, created by nature itself to survive in any conditions. In Japan, a fully automated factory for producing such cyborgs is already operating. The system can process dozens of insects per hour. Artificial intelligence controls every stage, from selecting suitable specimens to final testing of the completed biorobots. A German startup has raised 10 million euros to develop a project for combat cockroaches with targeting and communication systems. Algorithms are being developed to control entire swarms, where hundreds of cyborgs act as a single organism, coordinating their actions and exchanging information. At the same time, cockroaches and bees are only the beginning. In Australia, scientists are creating rescue beetles that can search for people trapped under rubble. Researchers from the University of Queensland have turned darkling beetles into real search and rescue workers. These insects, up to 3 centimeters long, can carry electronic equipment equal to their own body weight. Cyborg beetles are controlled using a regular gamepad, just like in a video game. The operator can make them move in any direction, climb walls, and overcome obstacles. In experiments, beetles successfully overcame barriers as high as their own bodies in 92% of cases. Switching from a horizontal to a vertical surface succeeded in 70% of attempts, a record among all similar developments. They are equipped with miniature cameras, microphones, motion, and heat sensors. Beetles penetrate rubble after earthquakes, building collapses, and mine explosions. They search for signs of life and transmit the coordinates of survivors to rescue teams. They can work in complete darkness, in smoke-filled rooms, and in areas of high radiation. The Australian scientists plan to conduct trials in real emergency conditions within the next 5 years. If the technology proves effective, armies of rescue beetles will be deployed worldwide. In the United States, the Massachusetts Institute of Technology and Harvard University have been working for more than 10 years on creating fully artificial insects, robo-bees. These tiny machines, the size of a real bee, can fly, hover in the air, and land on various surfaces. Robo-bees weigh only 1/10 of a gram, with a wingspan of 3 centimeters. Their wings beat at a rate of 120 times per second, powered by piezoelectric actuators, artificial muscles made from ceramic strips. Recently, they were equipped with new landing gear inspired by the legs of crane flies, which allowed them to avoid crashes during landings. For now, robo-bees remain tethered to external power sources through ultra-thin wires. But scientists are working on autonomous versions with built-in batteries and navigation systems. In the future, they are planned to be used for artificial pollination of plants, environmental monitoring, and search and rescue operations. Even cicadas have come under the control of scientists. In Japan, a technology has been developed that makes these insects produce sounds on command. Special electrical impulses activate their sound organs, turning cicadas into living loudspeakers or signaling devices. In 2025, insects became allies of humans in the fight against global threats for the first time in history. China was the first country to use this approach on an industrial scale. Predatory mosquitoes were deployed to stop a real epidemic. Cyber bees were tested in laboratory conditions for future use in reconnaissance and rescue missions. Technologies for mass production of biorobots without human involvement were created. The world is closely watching these developments. Other countries are already beginning to copy the Chinese approach. The European Union has allocated billions of euros for research in biorobotics. The United States has launched secret programs for the military use of cyber insects. Russia, India, Israel, all leading powers are investing in these technologies. Cyber insects are becoming a universal tool. They can be both a weapon and a rescuer, an observer and a transporter, a soldier and a doctor. In our time, the boundaries between nature and technology are disappearing for good. The most dangerous animal in human history is the mosquito, but now other insects, enhanced by 21st-century technologies, are working against it. This is no longer science fiction or a distant future. This is reality unfolding right now, and this is only the beginning of the bio-cyborg era, when living nature and artificial intelligence unite to solve tasks that neither could accomplish alone.